So when I call your names, you please put your camera on so that I can able to see you. Okay. Okay, let's give me attendance first. Rishabh, are you there?
Yes,
Rishabh?
ma'am. Present, ma'am.
Okay, thank you. Then Mrinmoy Bormon, Mrinmoy is absent. Kumari Amisha,
Present, ma'am.
okay, put your camera on. Okay, thank you. Akhil,
Present, ma'am.
put your camera on.
Yes, ma'am. It is turning on.
Thank you. Onkon, Onkon, Onkon,
Yes, ma'am. Ankun De, ma'am.
yes, Onkon Hauladar. Oh, there are two Onkon in your in section B too. Oh, that I don't know. So I will. Yeah. Prashant Giri.
Present, ma'am.
Okay, thank you. Victor Mondol. Victor Mondol. Kaushik Mahata.
Yes, ma'am.
Where are you? Okay, put your camera on, please.
Yes,
Okay,
ma'am.
thank you. Saurabh Sheth,
Yes, ma'am.
put your camera on. Shreya Giri.
Present, ma'am.
Okay, thank you. Onkon De.
Yes, ma'am.
Onkon De. Okay, thank you.
Yes.
Rajesh Kumar.
Yes, ma'am.
Thank you. Anish Agarwal. Thank you. Harsh Kumar Upadhyay.
Present, ma'am.
Harsh. Thank
Present,
you.
ma'am.
Avinash Kumar.
Present, ma'am.
ক্যামেরাটা অন করো।
Yes, ma'am. I've done that.
Thank you. Rahul Agarwal.
Yes, ma'am. Present, ma'am.
Thank you. Sheikh Mohammed.
Present, ma'am.
Thank you. What is your roll number? There is another Shakir Mohammed. I am calling Sheikh Mohammed.
Ma'am, that's my full name,
Sheikh.
Sheikh Mohammed Shakir. It is in two line.
Oh, your roll number is 1175.
Yes, ma'am.
Okay, thank you then. Aman Kumar.
Present, ma'am.
Thank you. Amritangshu Kumar. Amritangshu.
Present. Present, ma'am.
Okay, thank you. Abhimanyu Kumar Soni.
Present,
Abhimanyu.
ma'am. Present, ma'am. Present.
Camera, put your camera on.
Yes.
Arshit Mathur.
Present, ma'am.
Thank you. And last, Pooja Datta. Pooja.
Present, ma'am. Present, ma'am.
Thank you.
Ma'am, I'm Victor Mandal. Maybe I joined later, a bit later.
Yeah, I have already given you attendance.
Oh,
Okay,
thank you,
put
ma'am.
your
Thank you.
camera on. I would like to see you. Camera ta
Can you see
on
me?
koro.
Yes, ma'am. Can you see me?
No.
Ma'am, maybe.
Oh, now I have seen. Okay, thank you very much. Okay,
Okay,
let
ma'am.
me start now. হ্যাঁ কি হয়েছে বলো
Ma'am,
what
Kishan Kumar
happened
Singh. Ma'am, my attendance. Kishan Kumar Singh. Roll number 181, ma'am.
Kishan Kumar 181.
Yes, ma'am.
Oh, you are in B2 but your name is not in the roll sheet that I have got from Professor S. Scott Choudhury. So what is your roll number?
Ma'am, 181, just after Pooja Datta.
Oh, Kishan, what is your full name? Kishan Kumar.
Kishan Kumar Singh. Yes, ma'am.
Kishan Kumar Singh.
Yes, ma'am.
And your roll number 1181.
Yes, ma'am.
181.
Yes, ma'am. 1181.
Okay. Okay, let me start. The screen is visible.
Yes, ma'am.
Hello. Okay. So the laboratory experiment that we are going to study today is the testing of a current transformer by an absolute method. And here we are going to by doing an experiment on current transformer, what we will do, we are going to find out the ratio and phase angle error of a current transformer. Now, can you tell me why we call this experiment to be current transformer testing, not calibration, current transformer calibration or calibration of a current transformer? Have you go through the lab sheet? You have already received your lab sheet, isn't it? No? Hello? Yeah, so based that, because you have you go through it, na, the lab sheet. So why instead of calling it to be a current transformer testing, we don't call it a calibration of current transformer or current transformer calibration? Yeah. And why we call it an absolute method? Do you have any idea? You have done voltage the experiment on voltage testing of voltage transformer. That is also an absolute method. So you didn't know. Now here what we are going to get, we are going to find out ratio and phase angle errors of a current transformer. And while we are going to check the ratio and phase angle error, or we are going to deduce the formula for ratio and phase angle error for this particular experiment, we will see later on. Because we in the theory part we are going to find out what will be the expression for ratio and phase angle error of this current transformer under test by an absolute method. We call it an absolute method because ratio and phase angle depends on the components, absolute value of the components used in the experiment. That is, we will see the ratio error depends on the ratio of the resistor, and the phase angle is depends upon the capacitor and a resistor that we have used in the experiment. So since the both ratio and phase angle depends upon the absolute value of the components that we have used to perform to find out the ratio and phase angle, so we call this to be an current transformer testing by an absolute method. Now before now you know why we use current transformer. Why we use it? Hello?
Ma'am, to measure the current of another circuit.
To measure current in another circuit.
For like in high voltage lines or something.
Ma'am, it is used to step down the current so that we can easily measure values of high current using regular instruments without causing them damage.
Yes, that is the reason. But why don't we use, we know And we know that both current transformer and voltage transformer, they together are termed as an instrument transformer. And the main purpose of using instrument transformer is that they are used as an extension range of an AC instrument. Now, if we want to say, current transformer, if we want to, if this used as an extension range of an AC instruments, that means AC ammeter. So can't we extend the range of AC ammeter by using a shunt? So why we go for a current transformer? Because shunt is very simple instrument, because if it is nothing but a low value resistor. So why we are not using shunt to increase the range of AC ammeter? Why we use current transformer? Maybe due to accuracy.
Ma'am, if we isolate the measuring circuit from the main circuit, then ma'am, it is safer and easier to work with a low current side and measure the values.
Yeah, that is the one reason. One of the reason, because the transformer, both since there is no electrical connection between primary and secondary winding of a transformer, so we can isolate the measuring circuit from the actual circuit of which we are going to measure the current. But besides that, what are the disadvantage of using shunt? This is one of the disadvantage of using shunt, because if we using shunt, then we have to connect ammeter in same high voltage, high current circuit in series with that. Say we are going to find out the current flowing through the load, and the voltage across load is very high, and the current flowing through it is also high, and we are going to measure ammeter. We are using AC ammeter to measure that current, and we can use shunt. There the shunt should be connected in parallel across an AC ammeter, but we are not using shunt here. Besides this disadvantage, that means the measuring circuit and the actual circuit are isolated from each other with the help of CT. What are other disadvantages?
Ma'am, the shunt might also cause some power dissipation that we don't want.
Yeah, power dissipation also, but main point is what? When we connect shunt on AC supply, then what will happen? How the division of current depends upon that, means through ammeter and through shunt. What will be the ratio of the two currents? If it is a DC ammeter, then what will be the ratio? If I1 be the current flowing through ammeter and I2 be the current flowing through shunt, then you are saying that I1 by I2 will be equals to R2 by R1. So in case of when we are connecting it on AC supply, then what will happen? Does the division of current depends only upon the ratio of the resistances or anything else?
Ma'am, is it because the shunt will have some inductance?
Yeah, we have an inductive reactance as well as resistance. Now, or it will, we say that it will depends upon the impedance of the two paths. And the impedance of two paths will depends upon the frequency term omega. So it will, if the frequency changes, the division of current will also change. But we want to make division of current independent of frequency. For that reason, what we have to do? I am asking if we are using DC supply, then the ratio of the two currents will depends upon the ratio of the resistance of the two paths. Now, when we are using AC supply, then the ratio of current will phase angle. Due to phase angle, the division of current will change.
No, ma'am. Ma'am, the impedance will vary if the frequency of the supply changes, and therefore we will
Yeah,
get
so in
different
order to,
results.
so what we have to do, we have to make the ratio independent of frequency. How could we do that? Oh, the disadvantage, for this disadvantage of shunt, we will again go for a CT. আচ্ছা তোমরা কি কারেন্ট ট্রান্সফরমার, পোটেনশিয়াল ভোল্টেজ ট্রান্সফরমার আর পোটেনশিয়াল ট্রান্সফরমারটা কি পড়োনি? না, এগুলো এত মানে এখন আর মেজারমেন্টস এর এই সমস্ত টপিক গুলো পড়ার দরকার নেই বলে তোমাদের এগুলোকে পড়ার উপযুক্ত বলে মনে হয় না। আমি অনেককেই দেখেছি বেসিক বেসিক জিনিসগুলোই জানো না। How could we make this independent of frequency? For this, we need time constant of shunt branch and time constant of an ammeter should be perfectly matched with each other. Now, what will be the time constant of the shunt branch? Time constant টা কি হয় RL সার্কিটের? R by L না L by R? এইগুলো তোমাদের মনে রাখার মানে তোমাদের মনে রাখো না ইচ্ছে করে, না জানো না বলে, নাকি এই সাবজেক্ট গুলো একদম মানে মেজারমেন্টস কোনো পড়ার বিষয়বস্তুই নয় সেই কারণে এগুলো মনে রাখো না? So if we are using shunt on AC supply, another disadvantage is that we have to match the shunt that we are using to extend the range of AC ammeter. The time constant of shunt branch should be perfectly matched with the time constant of the ammeter, whose range we are want to increase with the help of shunt. So we need for different ammeter, we have to design different shunt. So this is another disadvantage besides isolation, besides power loss, because for high current, because shunt will carry most part of the current, so the power loss in shunt, which is I square R loss, will be more if we are using shunt on AC supply. So these are the reasons why we use current transformer to extend the range of AC ammeter in AC supply. Now, how could we see that how the CT can be used as an extension range of AC ammeter? Can you explain it to me? Hello. Hello, I am asking something. হ্যালো, কি হলো? এটাও বলতে পারছো না? I am asking how we are using CT as an extension range of AC ammeter. And then how we will connect CT? How we will connect primary and secondary winding of CT?
Ma'am, primary will be connected.
Yeah, tell me.
Ma'am, the secondary will be connected to the ammeter and the primary we will connect with the main circuit.
How it will be connected? If suppose if it is a voltage transformer, so how the primary winding now distinguish between voltage and voltage transformer and current transformer. If we want to connect, say we have a high voltage, high current line, and we want to measure high voltage, then how we will connect voltage transformer? Voltage transformer in line and current primary winding of voltage transformer in line and secondary of the voltage transformer across measuring instruments. Just like you have said, current transformer is connected in line and primary winding is connected in line and secondary winding is connected across measuring instrument, which is nothing but an ammeter, AC ammeter in case of a CT. Same you will be said. Same thing. এই তোমাদের এই বেসিক বেসিক জিনিসগুলো কেন গো, মানে কেন তোমরা বলতে পারো না? আমি তো সেটা বুঝতে পারছি না। কি
No, ma'am,
হবে?
it's not same. It's voltage transformer is connected via fuse in a little, like it's not connected directly by the line.
Via fuse.
The via fuse
Voltage
in
primary winding will be connected across the line. Voltage primary winding of VT connected across the line because we are measuring voltage.
Yes,
We
ma'am.
will measure voltage across a line, and in current transformer, we call it to be an equivalent, which is measuring current. So it will be connected in series with the line, just like an ammeter. তো এইটা বলতে পারছো না? এইটা জানো না? না না জানো হয়তো, কিন্তু মানে বলছো না আর কি, মানে এগুলো তো যখন তোমাদের ইলেকট্রিক্যাল মেজারমেন্টস বা তোমাদের এইগুলো পড়ানো হয়েছে তখন এইগুলো মানে ঠিক মতো এগুলো তো আমাদের দরকার নেই, অনেক ভালো ভালো সাবজেক্ট আছে, মানে সেগুলো জানলেই হবে, এগুলো না জানলেও চলবে, সেই জন্য এগুলোকে নেগলেক্ট করেছো আর কি, সেই জন্য এই সামান্য বেসিক বেসিক জিনিসগুলো তুমি বলতে পারছো না। করবে তো গিয়ে আইটি কোম্পানিতে চাকরি, কোর কোম্পানিতে তো আর চাকরি করবে না, তাই জন্য আমাদের আর এগুলো জানার দরকার নেই, তাই তো? হ্যাঁ, কি মনে হয় তোমাদের? I am asking something. So when we are going to connect a current transformer to measure current in a high voltage, high current circuit, we will connect primary winding in series with the line, and the secondary winding is connected across and across secondary terminals of CT, we will connect measuring device or measuring instruments, and in case of CT, the measuring instrument is nothing but an SE ammeter. So if we have a 1000 by 1000 ampere by 5 ampere CT, then and we are going to measure 1000 ampere current in high voltage, high current line. So, and if we know the ratio of CT, so by using an ammeter whose full scale range is 5 ampere, because secondary current flowing through the secondary winding of a transformer is 5 ampere, the CT that we have taken, 1000 ampere by 5 ampere CT. So by using an AC ammeter whose full scale value is 5 ampere, we can measure 1000 ampere current with that ammeter, because ammeter is a measuring device, measuring instruments. We will measure 1000 ampere current flowing through a high voltage, high current line. Thus, the AC ammeter whose range is 5 ampere, we can measure 1000 ampere current. So the range of AC ammeter will be extended from 5 ampere to 1000 ampere. Or and another disadvantage is also using shunt, that we have to connect ammeter in series with the line, and the insulation of the AC ammeter should be so that it will withstand that amount of high voltage. So now we go for our experiment. So here we are connected CT, say we have a 3-phase supply here, and we have connected CT in B phase. We will connect, primary winding is connected in series with the line. And a secondary winding, we have seen from the figure, it is connected across a measuring device, which is nothing but an AC ammeter. Now there are what is the nominal ratio of a current transformer? Current transformation ratio is primary current by secondary current. Now what will be the nominal ratio? Is it same, primary current by secondary current?
Ma'am, rated primary current to rated secondary current.
Yes, rated primary current by rated secondary current is the nominal ratio of a CT. And the rated means the current that the transformer primary winding can able to carry without excessive temperature rise. or we can say the nominal ratio should be written on the nameplate of a current transformer. And since the transformer is not being ideal, so the nominal ratio which has been written on the nameplate of a transformer will differ from the current transformation ratio, which is the current flowing through the primary winding divided by current flowing through the secondary winding. Now, why the ratio differs? And also there, for an ideal CT, nominal ratio will be equals to current transformation ratio will be equals to turns ratio of CT. Now, what is the turns ratio of CT? In terms of number of windings? From there?
Ma'am, it's number of turns in the secondary divided by the number of turns in the primary.
Yes, I am asking in terms of number of turns in the windings. Yes, number of secondary turns divided by number of primary turns. And what is the burden besides nominal ratio, current transformation ratio, and what is that turns ratio? How we define burden on CT?
Ma'am, it's the external load that we are applying to the secondary.
Load means only current. That is burden. Then? Then it's what will be the unit of a burden then?
Ohms.
Ohms. Okay. Besides ohms, there is another unit of a burden. Actually, in CT, the burden is written on the nameplate of CT, that is in volt ampere. Now, can you tell me what is that volt and what is that ampere? Volt ampere. So what is the voltage? আমাকে তো voltage into current করতে হবে, তাহলে আমি কার voltage কার current multiply করব to get volt ampere? হ্যাঁ, সেটার ডেফিনেশনটা কি হবে? If আমার তো এখানে আমি দেখলাম যে নমিনাল রেশিও রেটেড প্রাইমারি কারেন্ট বাই রেটেড সেকেন্ডারি কারেন্ট। সো অ্যান্ড কারেন্ট রেশিও হচ্ছে প্রাইমারি কারেন্ট ইনটু সেকেন্ডারি কারেন্ট। তার মানে এটা কি সেকেন্ডারি টার্মিনাল ভোল্টেজ ইনটু সেকেন্ডারি কারেন্ট সিম্পলি? No, it will be the rated secondary terminal voltage at rated secondary multiplied by rated secondary current. Say we have 1000 ampere by 5 ampere CT, or say the and we have a 200 volt ampere burden. Then what will be the rated secondary terminal voltage? Yes, so that will be the burden, rated secondary terminal voltage into rated secondary current, not secondary current into secondary terminal voltage. It should be rated. তাহলে তো আমরা কারেন্ট ট্রান্সফরমেশন রেশিওটা না বার করে আমরা নমিনাল রেশিও দিয়ে we can say the CT has only a nominal ratio. So why we go for a current transformation ratio? তুমি রেটেড কথাটা তো বলনি, if you don't put the term rated then your answer will not be complete. Okay,
Okay, ma'am.
you have to mention that rated secondary current. So now we are to find out the ratio and phase angle of a CT, we have to consider the phase angle. Sorry, we have to consider the phasor diagram of CT. So this will be the phasor diagram of CT, which is more or less equivalent to the power transformer. So we have in power transformers, we have taken phi as a reference phasor because the flux phi is common to both primary and secondary winding. And Im is the magnetizing current, IE is the hysteresis and eddy current plus component of the current, and I0 is the phasor sum of Im and IE, or we call it to be a no load component of the primary current, which is IP and IS. IP is the primary current and IS is the secondary current, and ES is the secondary induced voltage, and VS secondary terminal voltage. This will be ISRS and this is ISXS. It will give us ES, and reverse secondary current is IP prime, and the phasor sum of IP prime and I0 will give us IP. And we are to find out, since the nominal ratio is being written on the nameplate of a transformer, we have to find out the current transformation ratio, which is IP by IS, primary current corresponding secondary divided by corresponding secondary current. So to find that ratio, here now here we are going to find out the IP by IS. We are going to find out. Now here, actual in this experiment, we are going to find out this ratio of IP by IS in terms of the components we are using to make the current transformer circuit to find out its error. But actually, theoretically, what will be the ratio of IP by IS equals to what? Do you remember that expression? With what will be the ratio of IP by IS in terms of IM, IE, and this delta? This is the phase angle of the secondary of CT, and the alpha is the angle between here, or from the diagram it is angle between I0 and Im. Yeah, now I am what is the how the IP by IS is related with all these terms? It is it is like that. Then IP equals to root over IP square, IP prime square plus I0 square. Then how could we relate I0? হ্যাঁ ভেক্টর সাম হবে সেটা তো জানি, কিন্তু সেই ভেক্টর সামটাই আমি কি করে বার করব? It is the not, sorry, I have said wrong, square root of this. It will be IP phasor will be equals to phasor sum of IP prime and I0 prime. Sorry, I0, if we relate phasor to be I0 bar and IP prime bar, IP bar will be equals to, because to denote it is a phasor, so we call it to be IP bar, and IP bar will be equals to IP prime bar plus I0 bar phasor sum. But what will be the end? I am asking about the end result, jeta theoretically ashe. Here though we are going to find out experimentally what will be the ratio, because we have used one circuit to find out the ratio. But আমি theoretically জিজ্ঞাসা করেছি প্রথমে, এগুলো তো পড়োনি, আমি তো বুঝতেই পাচ্ছি। আর তোমাদের এমনিতেও তো তোমরা তোমরা you have performed offline laboratory class only in second year first semester, isn't it? তাহলে সেখানে তোমাদের যখন তোমরা ল্যাবরেটরি করতে আসার আগে তোমাদের তো যেদিন যেই ল্যাবরেটরিটা দ্য ল্যাব ইউ আর গোয়িং টু পারফর্ম, ইউ হ্যাভ টু স্টাডি দ্যাট মেটেরিয়াল না? তাহলে এইখানে আমি বলছি না তোমরা পড়োনি কেন, কিন্তু তোমাদের তো এটা থিওরিতে পড়েছো, যেহেতু সেকেন্ড ইয়ারে পড়েছো সেজন্য এগুলো কোনো কিছুই মনে রাখার দরকার নেই, আর মেজারমেন্ট তো আরোই দরকার নেই, সেই কারণে তো। I0 bar আর I0 bar will be IM bar আর IE bar, সেটাও ফেজার সাম। I0 bar, তাই সেই ফেজার must have a magnitude as well as angle. এটাকে যদি আমি তোমার পোলার নোটেশন করি তাহলে it should be a angle theta. So what will be, আমাকে ম্যাগনিটিউডটাও বার করতে হবে, ফেজ অ্যাঙ্গেলটাও বার করতে হবে, তাহলে সেটা আমরা কি করে করব? তুমি কি you don't have to taken into account the phase angle? তাহলে phase angle দিয়ে করে কি হচ্ছে বলো তো? I0 বারটাই বলো আগে কি হবে? হ্যাঁ, so we have to take that two component into account. তারপরে এন্ড রেজাল্টসটা বলো, ওগুলো তো বলতে বলতে তো আমারও মানে আমি কিছু বুঝতে পারছি, মানে বুঝতে পারছি কিন্তু আমি অতটা মনে রাখতে পারবো না। এন্ড রেজাল্টসটা শুধু বলো কি হবে? হুম, তাহলে এন্ড রেজাল্টসটা কার উপর ডিপেন্ড করবে? তাহলে তোমার মতে কি কোন কোন মানে the current transformation ratio depends upon what? মানে IP by IS, how it is being related with IM, IE, delta, alpha. Yes, IS also. তা সেই জন্যই তো আমি বলছি, জিজ্ঞাসা করছি কি হবে। হ্যাঁ, তাহলে এন্ড রেজাল্টসটা তো বলো কি করে রিলেটেড। IP by IS, how related with I0, alpha, delta, IM, IE. I0 বললে IM, IE is included in I0 because we are finding out the ratio. It will be the ratio of IP by IE will be equals to N plus I0 sine alpha plus delta divided by IS, where N is the turns ratio and I0 is the component, no load component of the primary current, or one of the component of the primary current. I0 N plus, where N is the turns ratio, N plus I0 sine alpha plus delta divided by IS. বুঝেছো? Or বুঝতে পেরেছো? So in this way it is related with IP by IS is related with alpha, delta, current I0 and turns ratio. That is why if the transformer, this is the current transformation ratio of an actual current transformer. If it is ideal, then I0 sine alpha plus delta by IS, this part will be 0. And IP, current transformation ratio, which is primary current by secondary current, will be equals to the nominal ratio equals to the turns ratio. বুঝতে পেরেছো? Now, but here, what we have used to find out the ratio between IP and IS, here IP is the current flowing through the, this is the test CT, and IS is the current flowing through the primary winding, and IS is the current flowing through the secondary winding. And here we have formed a bridge circuit, and it is an AC bridge. Now, can you tell me by C, and we are using the selector switch position in position 1. তাহলে what are the 4 arms of this AC bridge? কি কি হচ্ছে? আমি তুমি all the time you are answering my question, আর নয়তো শ্রেয়া আমার কোশ্চেন আনসার করছে। আর সবাই কি ঘুমিয়ে আছে? আমি অন্যদেরকে জিজ্ঞাসা করছি। টেল মি। এখানে অলরেডি দুজন প্রথমে থেকে সবাই প্রেজেন্ট ছিল প্রথমে, এখন অলরেডি দুজন আউট। আমি এখানে অ্যাটেন্ডেন্স দেখছি 20 জনের। আরে আর সবাই কোথায় গেল? আনসার মি। হ্যালো, কেউ নেই
Yes,
মনে
ma'am.
হয়। আমি তোমাকে জিজ্ঞাসা করিনি শ্রেয়া, তোমাকে আর অনিশকে আমি জিজ্ঞাসা করিনি,
Okay, ma'am.
আমি অন্যদেরকে জিজ্ঞাসা করছি। তারা সবাই ঘুমিয়ে আছে কিনা কে জানে, অ্যাটেন্ডেন্স দিয়ে ঘুমিয়ে পড়েছে মনে হয়, এখন তো আফটারনুন, ঘুমাচ্ছে বাড়িতে মনে হয়। তারপরে আবার যখন ক্লাস শেষ হবে জানতে পারবে, ফোন যাবে তোমাদের কোনো কারোর থেকে, তখন আবার জেগে উঠে অ্যাটেন্ডেন্সটা দেবে। হোয়াট ইজ দিস? কি হলো দেখি তো। এই ভিক্টর মন্ডল কোথায়? ভিক্টর মন্ডল, হ্যালো।
Yes, ma'am. Yes, ma'am.
Answer me, how the AC bridge is formed? The diagram is visible to you, the circuit diagram.
Yes, ma'am.
Tell me how the AC bridge is being formed here to find out the ratio between IP and IS. এতক্ষণ শুনছিলে আমি কি বলছিলাম? Are you listening?
Yes, ma'am.
What I have said so far?
ম্যাম অ্যাকচুয়ালি কানেক্টিভিটির প্রবলেম, তো অনেকটা দূরে আছি, সেজন্য একটু অসুবিধা হচ্ছে আমার।
এগুলো হচ্ছে, these are nothing but the excuses. অমৃতাংশু, হ্যালো। অমৃতাংশু, আর আরেকটা কে? অমৃতাংশু, তারপরে আরেকটা কে? কুমারী অমিশা নাকি আনিশা?
Yes,
সে
ma'am, I'm here
কোথায়?
only. I answered in between also.
You are not attending my classes, elective class. You have a measurement elective, isn't it?
No, ma'am. I have machine
Oh,
selective.
so your elective is what?
Machines.
Machine. Oh, okay, sorry for that then. Then besides, there is one girl there, Pooja Datta. Pooja, you have a measurement elective?
No, ma'am.
তাহলে কার?
ঐশানীর আছে ওটা।
ও ঐশানী, ও বোধহয় মানে বিভানে না? সরি।
Ma'am, she's in section A.
ও সেকশন এ তে, আচ্ছা সরি। হ্যাঁ, কোথায় অমৃতাংশু? আর ইউ দেয়ার? কি অবস্থা! Okay, tell me now, what will be the forearm of the bridge? Here RP and RS, these are the two low resistances connected in series with the primary and secondary winding. So here one arm of the bridge is formed by this primary resistance RP. Another arm will be, since when we are using selector switch in position 1, then
C
R1 is
parallel.
parallel, R1 will be parallel with C. So R1 parallel with C, this is another arm. Third arm is R2 and the fourth arm is RS. And we have a detector in between. So at the balance condition of the bridge, when there will be no current flowing through the detector or voltage across the detector will be 0, then we have these two equations. isn't it? হ্যাঁ করছি। হুম 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 না আমি তো আরো ছোট করতে চাইছি, তা যাতে তুমি বুঝতে, তুমি কি বড় করতে কেন চাইছো? আমি তো ছোট করলাম এটাকে, যাতে তোমরা ইকুয়েশন দুটো দেখতে পারো। এই তো, this will be the bridge and this will be the two equations. এইটাই তো ছিল, তুমি আমাকে আবার কি করতে বললে ভগবান জানে। তোমার তো এইটুকু সার্কিট দেখতে পেলেই হলো, এই সার্কিটটাকে যদি আরেকটু ছোট করে দিই সিলেক্ট করে, তাহলে তোমরা আরো তোমার তোমার ইমেজ, তুমি যেটা দেখছো সেটা ডিস্টর্টেড হয়েছে।
না ম্যাম, বোঝা তো যাচ্ছে।
তাহলে তোমার কিছু প্রবলেম, আমার এখানে তো সবাই কি বুঝতে পারছো ইকুয়েশন দুটো, নাকি ইকুয়েশনটা মানে
Yes, ma'am.
ডিস্টর্টেড
Correct.
হয়ে আসছে?
Yes, ma'am.
ইজ ইট ওকে?
Yes, ma'am.
Yes,
আনিশ,
ma'am, it's
তুমি হয়তো
visible.
তোমার ইয়েতে হয়তো দেখতে অসুবিধা হচ্ছে, তোমার কিছু প্রবলেম হচ্ছে, দেখেছো? ওকে, দেখতে পেয়েছো ইকুয়েশন দুটো? Is these two equations are okay or not? Okay. Now I am again go to 100%. So this will be the two equations. And now we are going to write the ES, IS and IP in terms of its magnitude and phase angle. And we have taken here ES as reference. So ES bar will be ES angle 0 degree. IS will be IS bar. Go to the phasor diagram, IS bar. Since we have taken ES as a reference phasor, so ES will be ES angle 0 degree, IS and IS lagging ES by an angle delta. So IS bar will be IS minus delta and IP will be, so see here, this will be IP. Remember this diagram, IP will be IP minus delta minus theta 180 degree minus delta minus theta. Isn't it? So this has been written over here. IS is ES is ES angle 0 degree, IS bar IS angle minus delta because it is a lagging angle, and IP will be 180 degree minus delta minus theta. Now from relation this one, we are going to put the values. So Ix here, R1 and 1 by j omega c parallel combination, it will give us R1 by j omega c R1 and IP RP. Now this will be equals to Ix bar R1 and IP bar Rp into 1 plus j omega C R1, and ultimately the end results will be this. Go through this. I'm not going to আমার এগুলো বারবার বলতে ইচ্ছে করছে না. So this will be Ix bar R1 equals to Ip. Now Ip, it has been written here in terms of magnitude and phase angle. Are you agree? Now here R1 that has been taken, it is in kilo ohm and C is in microfarad. So when we are going to multiply this omega C R1, it will be very, and we are taking square of this. So it will be less than 1. So we are going to neglect omega C R1 square. Then this Rp root over this magnitude will be, we have taken it to be equivalent to Rp. And then this relation is converted to this. So this, now recalling relation 2 using 4, what is the equation 2? This is equation 2 and this is equation 4. So in equation 2, in terms of in place of Is, we are going to write it in terms of its magnitude and phase angle. So it will be Is minus delta. So Ix bar R2 will be Is Rs minus delta, and then dividing 6 by 7, we got this. Clear? From here, so we what we are getting, R1 by R2 will be equals to IPRP ISRS, and this will be the angle. Clear? Now we are going
Yes,
to, this will be the magnitude and this will be the phase. So from magnitude relation, R1, R2 will be IPRP by ISRS. Now RP and RS, they are same. So IP by IS will be equals to R1 by R2. Now since, and this is the current transformation ratio, and since the current transformation ratio is depends upon the absolute value of resistances R1 and R2, in order to find out the ratio and phase angle of this CT, so we call it to be an absolute method. And also we will see later on the phase angle will be depends upon these resistor and capacitor values. Now what will be the phase angle? Now I am going to find out that. Now, but before that, tell me, now up to this it is clear to you, isn't it? IP by IS will be equals to R1 by R2. Clear to? আরে আমি সবসময় শুধু তোমাদের দুজনেরই গলা শুনতে পাচ্ছি, আর সবাই কি করছে ভগবান জানে। Now how we define phase angle of CT? হ্যাঁ, phase angle of CT টা কোন অ্যাঙ্গেলটা? না, কি করে, কোন অ্যাঙ্গেলটাকে থিটা হিসাবে নেওয়া হয়? IS এর অ্যাঙ্গেলটা with
the angle
respect
between
to
I and V. Current and
I and V.
Ma'am, the angle between primary current IP and the secondary current IS in when reversed order.
Yes, it will be the angle between primary current and reverse secondary current. What will be the ideal angle? If the CT is ideal, what will be the phase angle? 180 degree. Yes. So since the CT is not being ideal, so we have a phase angle error in the CT has a phase angle. There will be difference between IP and reverse secondary current, which is nothing but IP prime or NIS. N is the turns ratio. So, and how could we find that phase angle? In this, for this experiment, it will be from relation C. So this is C. Now here, this is the magnitude relation, isn't it? And this is the relation between the angles. Now, are you agree with this equals to 0? রেজিস্টার রেশিও, এটা তো রেজিস্টারের ফেজ অ্যাঙ্গেল তো 0 হয়, দ্যাট ইজ ওয়াই ইট ইজ 0, বুঝেছো? So from here we are ultimately what we are getting, theta will be equals to tan inverse omega c r1, and this is a phase angle of CT, that means not ideal CT, actual CT. And this is treated as an error because actually the angle will be or ideally the angle will be 180 degree, but instead of 180 degree we are getting angle theta, so it is treated as a phase angle error. Clear? Now the phase angle error is depends upon again C and R1. So we call this to be current transformer testing by an absolute method. Clear?
Yes, ma'am.
হ্যাঁ হ্যাঁ, আরপি ইকুয়ালস টু আরএস নিয়েছি, আর আরপি ইকুয়ালস টু ওই রুট ওভার, যেহেতু আরপি রুট ওভার দিস ইকুয়ালস টু আরপি নিয়েছি। হ্যাঁ, ইয়েস, we have neglecting omega c r1 whole square. এইখানে এইটা কেন প্লাস হয়ে গেল? এইটা কি আছে এখানে দেখো, হোয়াট ইজ দিস? দিস ইজ ইনটু, তাহলে when হ্যাঁ, তুমি কি, তোমার কনফিউশনটা কোথায়? ও, ডেল্টাটা তো কেটে গেছে, দিস মাইনাস ডেল্টা when it comes up it will be plus, so plus delta and minus delta cancels out. বুঝতে পেরেছো? Now the ratio error, it is the nominal ratio minus actual transformation ratio or current transformation ratio divided by nominal ratio into 100, and a nominal ratio I've already told you, rated primary current by rated secondary current, and that is the phase angle error. Now the apparatus required here from the same diagram what we have seen, we need, these are the R1 is the decade resistance box and C is the decade capacitance box, R2 is a fixed resistor, RP and RS, these are the low value resistor or low resistance, and that is why it is defined as 4 terminal. And this is burden. Here we have used in the experiment, the burden is a resistive burden. We are using here a variable rheostat. And this is the test city. The supply is the primary winding of a transformer is connected to the secondary winding of an isolation transformer, and the secondary winding is connected with RS ampere burden in series. So this will be the connection, and we are obtaining and the null by varying this, because this RP and RS, its value is here what it has been R2 is 2 kilo ohm, and RP and RS is 30 milliohm. So these are all the fixed value of resistances, and we will obtain null by varying these R1 and C. So under balance condition, we will get IP by IS equals to R1 by R2. And we are going to we are going to find out ratio and phase angle by with the we are performing 3 run. In run 1, we will test the CT at rated voltage and rated current. That means now, since we are using here 10 ampere by 5 ampere CT, so the nominal ratio will be 2:1, and the burden on CT is 20 VA, and this is the rated burden. This 10 ampere and 5 ampere, this ratio and this burden, it is being written on the nameplate of the test CT. But the actual ratio we have just found out from the phasor diagram from this experiment, and considering the phasor diagram of CT, it will be R1 by R2, and then the ratio correction factor, which will be the actual ratio minus nominal ratio. Now percentage ratio error will be 1 by RCF into 100. Therefore, it will be nominal ratio minus actual ratio divided by nominal ratio into 100. What I have written here, the ratio error. This is Kn by Kn minus R by Kn into 100. তোমাদের অসুবিধা হচ্ছে না তো বুঝতে? Because we are moving the screen, I am moving the screen ups and down. হ্যাঁ বলো। হ্যাঁ, তখন R2 and C in parallel হতো। তখন R1টা যেহেতু ভ্যারিয়েবল নিয়েছি, R2টা ফিক্সড, তখন R1টাকেই ভ্যারি করে করতে হতো। কিন্তু হ্যাঁ, ওটার জন্য ডেরিভেশন আলাদা, এটা শুধু খালি পজিশন 1 এর জন্য করা আছে। আমাদের তো দরকার নেই না, দ্যাট ইজ ওয়াই উই ডিডন্ট বদার অ্যাবাউট দ্যাট। Now, first, when we are performing the test, we will first find out ratio error at rated secondary current and rated secondary voltage. Now, from the nominal ratio, we have seen that the rated secondary current is 5 ampere. And since this is the rated burden, so the burden will be the rated secondary voltage, rated secondary terminal voltage, and into rated secondary current. And so when we divide 20 VA by 5, we will get 4 volt. That will be the rated secondary terminal voltage, and rated secondary current is 5 ampere. That is why here in first run, this is run 1, this is run 2, and this is run 3. So we have 5 ampere secondary current, we have 4 ampere VS. So rated at rated IS and VS. Now when we are going to perform the experiment by varying the burden and varying varying the load, then since burden is associated with two IS values, VS and IS, so when we are going to vary one value, we will keep other value constant. So in run 2, when we are going to vary IS, we are keeping ZS at its constant values. And how we are varying the secondary current, we will vary secondary current besides rated current, which is 100% current. We are going to find out ratio and phase angle at 120% of rated secondary current, 80% of secondary current. 60% and 40% of rated secondary current. And
Excuse me, ma'am.
that, yeah.
Ma'am,
Tell me.
machine people have their project presentation from 4 and we can at max extend it till 4:15. So can you please?
আচ্ছা তোমাদের আজ ও আচ্ছা সরি, কিন্তু এইটা যে ডিউরেশনটা তোমাদের তো আমার তো এমনিতেই যদি অফলাইন হতো তাহলে তো তোমাদের ল্যাবটা 3 ঘন্টার না, মানে 2:30 to 5:30, isn't it?
Yes, ma'am. This project.
তাহলে তোমাদের প্রজেক্ট প্রেজেন্টেশন কি করে থাকে?
Ma'am, sir has like just said the present. This project is of the previous semester only, and ma'am, sir has like finally
But
got
due to
time
some
today.
problems, sir scheduled this day, ma'am. Like
Yes,
it was to be happen
তোমরা you
earlier
didn't
semester
told
only.
us sir that you have a laboratory class with me today.
Yes, ma'am, we have said, but sir said that
এটা
like
এগুলো না, এগুলো হচ্ছে গিয়ে তোমাদের জন্যই এই সমস্ত হয়, স্যারের নামে দোষ দিও না। যদি তোমাদের যদি অন্য কিছু থাকতো, এটা তো মানে প্রি শিডিউলড, এটা অলরেডি শিডিউলড ক্লাস, তোমরা প্রজেক্টটা তোমাদের শিডিউলড নয় আজকে, তা এখন
ma'am, it
তোমরা
was
আমাকে বলছো তাড়াতাড়ি ছেড়ে দিতে, হোয়াট ইজ দিস?
ma'am, just 2 people, machine people.
আচ্ছা ঠিক আছে, শ্রেয়া তুমি আর কে?
Ma'am, I'm Amisha.
ma'am, I am
আমিশা?
I am
Yes,
Amish.
ma'am.
এখন এখন অনেকেই বলবে আমাকে। ওকে,
Ma'am, only two of us, ma'am.
টু অফ আস, শ্রেয়া ছাড়া আর কে?
Not
ম্যাম
Shreya,
আমার
ma'am.
নেই
Amisha
ম্যাম,
and
আমিষা
Akhil.
আর আখিলের আছে।
ও আচ্ছা আচ্ছা, আমিশা, কুমারী আমিশা, isn't it?
Yes, ma'am.
And
Akhil, ma'am.
Akhil.
Koilad Akhil.
oh, Akhil. Okay. Okay, if you have a project presentation, then you may leave now.
Ma'am,
Thank you, ma'am.
ma'am.
তোমাদের স্যার কে?
DC sir.
I'm DC, sir. Ma'am.
ডিসি স্যার। Okay. Now, when we are going to vary both VS and IS, because we are going to find out the ratio and phase angle at varying secondary terminal voltage and varying secondary current. And so first, when we are going to vary IS, we will keep ZS constant. And when we are going to vary ZS, we are going to keep IS at its rated value. So here when we are varying VS again in the same way, we are going to vary this, we will keep IS at 100% at its rated value. This current remain constant and the voltage is varying 120% of rated voltage, 80% of rated voltage, 60% of rated voltage, and 40% of rated voltage. And these are the values of R1 and C that has been obtained when the experiment is being done on a particular day when the classes are were on offline mode. So based on these values, you are going to find out the actual ratio, then ratio correction factor, percentage ratio error, and phase angle. These based on this formula, and after finding out the phase angle and ratio error, you are going to plot a curve, ratio error versus rated secondary current, phase angle error versus rated secondary current, ratio error versus rated secondary voltage, and ratio phase angle error versus rated secondary voltage. So now since we are performing this experiment at power frequency range, because the supply, we are exciting the city from 50 hertz supply. So power line interference sometimes cause a problem in order to obtain the actual null. Though here we are, the null detector that we have used here is not a tune detector. Now, what is the advantage of using tune detector? Can you tell me? হ্যালো, ও আমি টিউন ডিটেক্টরের ফাংশনটা জানতে চেয়েছি, তার সঙ্গে ক্যাপাসিটরের কোনো সম্পর্ক নেই। ভাইব্রেশন গ্যালভানোমিটারের ক্যারেক্টারিস্টিক্সটা টিউন ডিটেক্টরের ক্যারেক্টারিস্টিক্স এর মতো, সেটা জানো কি? টিউন ব্যান্ড পাস ফিল্টারের ক্যারেক্টারিস্টিক্সটা কি হয়? হ্যাঁ, ফ্লাকচুয়েট তো করে, উই আর নট গেটিং এক্সাক্ট নাল, মানে মিনিমাল ভোল্টেজের কাছাকাছি এলেই দেন উই উইল নোট দ্যাট ভ্যালু অফ R1 and C in this experiment, because here we are not using vibration galvanometer, we are using CRO here. ভাইব্রেশন গ্যালভানোমিটারটা আমরা ইউজ করতে পারতাম, কিন্তু ভাইব্রেশন গ্যালভানোমিটার আমাদের ল্যাবরেটরিতে নেই, সেজন্য আমরা সিআরও ইউজ করি। মানে ওটা ছিল কিন্তু মানে ওটা খারাপ হয়ে গেছে মনে হয়, দ্যাট ইজ ওয়াই মানে ইট ইজ বেটার টু ইউজ সিআরও, বাট সিআরও ইজ নট আ টিউন ডিটেক্টর, but vibration galvanometer is. Now why vibration galvanometer can be used as a tune detector, তোমরা জানো কি সেটা? আমি যে টিউন সার্কিটের ক্যারেক্টারিস্টিক্স কি হয় টিউন ব্যান্ড পাস ফিল্টারের? So gain peaks at center frequency. তাহলে gain peaks at center frequency মানে আউটপুট ভোল্টেজ will go high. আউটপুট ভোল্টেজের ম্যাগনিটিউডটা at center frequency তে বেশি হয়। ক্লিয়ার? The output peaks at center frequency. Now if we are using tune detector, then the output voltage, which is the voltage across the detector, it will be maximum, and when that maximum voltage is 0, then that will be a perfect null, and tune detector is suppressing all the voltages before and after center frequency, because the gain peaks at center frequency. It will suppress.
Understood, ma'am.
তাহলে আমরা যদি এই ডিটেক্টরের আগে একটা tuned amplifier, CRO we are using, since we don't have a vibration galvanometer, so we don't vibration galvanometer can be used as a tune detector, because if we can we can make vibration galvanometer behave as a tune detector at power line frequency, that means 50 hertz. Vibration galvanometer is an AC galvanometer, can be used at power frequency range, kintu CRO can be used for the various range of frequencies. That is why when we are performing a AC bridge experiments, instead of using vibration galvanometer, if we don't obtain the balance, if we don't want to balance the bridge at power frequency, we may use সিআরও। কারণ তোমরা এর আগে এসি ব্রিজের এক্সপেরিমেন্ট অনলাইনে যখন করেছো দেখবে আমরা 500 হার্টজ, 1 কিলো হার্টজ, 5 কিলো হার্টজ, এই দিস ওয়ে উই আর ভ্যারিং দ্য ফ্রিকোয়েন্সি টু অবটেইন নাল। করেছো তো এসি ব্রিজের এক্সপেরিমেন্ট অনলাইনে? আচ্ছা, তাহলে সেইখান থেকে তো নিশ্চয়ই জানো সেখানে ভাইব্রেশন গ্যালভানোমিটার, যদি আমরা পাওয়ার ফ্রিকোয়েন্সিতে এসি ব্রিজ উই ক্যান ব্যালেন্স অ্যাট পাওয়ার ফ্রিকোয়েন্সি অলসো, বিকজ উই হ্যাভ টু মেজার দ্য unknown components with the unknown value of L and C to by doing AC bridge, by balancing the AC bridge, isn't it? হ্যালো, কারণ শেয়ারিং ব্রিজ আর ওয়েন্স ব্রিজে তোমরা এল অ্যান্ড সি মেজার করেছো, শেয়ারিং ব্রিজ টু মেজার আননোন সি অ্যান্ড ওয়েন্স ব্রিজ টু মেজার আননোন এল অফ আ কয়েল, মনে আছে? মানে আমরা সেটার জন্যই আমরা শেয়ারিং আর ওয়েন্স ব্রিজ ইউজ করি, সেটুকু জানো তো? So we can balance the bridge at power frequency. So we can use vibration galvanometer as a detector, and vibration galvanometer, before using vibration galvanometer as a detector, we will tune vibration galvanometer at power line frequency so that output voltage will be high, and when that voltage drops to zero, then the perfect null is being obtained. বাট সিন্স হিয়ার আমাদের যেহেতু ভাইব্রেশন গ্যালভানোমিটার যেটা ছিল আমরা সেটা খারাপ হয়ে গেছে বলে আমরা এইখানে যে দিস এক্সপেরিমেন্ট অলসো ইজ বিং ডান অ্যাট 50 হার্টজ supply, but we are using CRO. So here power line interference will be there because CRO cannot be used as a tune detector. So in order to make CRO to behave as a tune detector, we have to use CRO with together with tuned amplifier, and output of the tuned amplifier will fed to CRO. And in that case, when we are going to balance the bridge, we will obtain maximum voltage maximum voltage across the detector for a particular frequency, and when that voltage drops to zero, that will be the perfect null. Clear what I have said? Okay, this is all about this experiment, and I will send you this data sheet together with the note, and you have to submit a lab report by next week. Next week কোন ডেটের মধ্যে জমা দেবে? That should be next Friday. Next Friday. Okay. Okay, now I will do your roll call again. So let me do that. বাবা, দুজন গেছে, তা এখন 18 জন, মানে 4 জন অ্যাবসেন্ট, দুজনকে তো আমি এমনিতেই ছাড়লাম। কি অবস্থা! ঋষভ,
Present, ma'am.
এই ক্যামেরাটা অন করো, ক্যামেরাটা অন করো।
Yes, ma'am. Present.
থ্যাংক ইউ। মৃন্ময় বর্মন, সে বোধহয় আজকে now Ankon Howladar, still he is absent today. Prashant Giri, Prashant Giri, একে তো আমি অ্যাবসেন্ট করে দেব। Victor Mondol,
প্রেজেন্ট ম্যাম।
হ্যালো, ক্যামেরাটা অন করো। কৌশিক মাহাতা, থ্যাংক ইউ। কৌশিক মাহাতা,
Yes, ma'am.
ক্যামেরাটা অন করো। তোমাকে দেখে মনে হয় তুমি ঘুমাচ্ছিলে আমি যখন তোমাদের ক্লাস নিচ্ছিলাম,
না
মনে
ma'am.
হচ্ছে আমার,
না না।
আমার মনে হচ্ছে তাই। সৌরভ শীত,
Yes, ma'am.
থ্যাংক ইউ। শ্রেয়া,
Present,
থ্যাংক
ma'am.
ইউ। থ্যাংক ইউ। অঙ্কন, অঙ্কন
Yes,
দে,
ma'am. Yes, ma'am.
থ্যাংক ইউ। রাজেশ কুমার,
Yes, ma'am.
থ্যাংক ইউ। অনিশ, থ্যাংক ইউ।
ম্যাম আমার মাইক কাজ করছিল না ম্যাম। প্রশান্ত গিরি।
তোমার ক্যামেরাটা অন করো এখন, আমি তোমাকে অ্যাবসেন্ট করে রেখেছি। মানে কোথায় তুমি? ও, তোমার ক্যামেরা অন হচ্ছে না, কি হলো? ও, থ্যাংক ইউ। নাকি তোমাকে কেউ ফোন করে দিল আর তুমি জেগে উঠলে ঘুম থেকে?
না ম্যাম, ল্যাপটপ নিয়েই বসেই আছি ম্যাম।
হর্ষ কুমার উপাধ্যায়, হর্ষ,
ম্যাম।
ক্যামেরা অন করো।
প্রেজেন্ট ম্যাম।
ক্যামেরা অন প্লিজ, পুট ইউর ক্যামেরা অন।
অন।
ক্যামেরাতে তো আমি তোমাকে দেখতে চাই।
ম্যাম ক্যামেরা ইজ অন।
নাও আই হ্যাভ সিন ইউ।
ইয়েস ম্যাম।
অবিনাশ কুমার,
Yes, ma'am.
ক্যামেরা অন।
Yeah, I've
Thank
done
you.
that. Yeah.
Rahul Agarwal, okay, thank you.
Yes, ma'am. Present.
Sheikh Mohammed,
Present,
thank
ma'am.
you. Aman Kumar, Aman Kumar, কোথায় গেল? ও, এ কি অ্যাবসেন্ট ছিল নাকি? দাঁড়াও দাঁড়াও, আমি একে অ্যাবসেন্ট করব। অমৃতাংশু,
Yes, ma'am. Present, ma'am.
thank you. But when I am asking question by calling your name, that time no response from you.
Ma'am, I went to washroom, keeping my phone to on my table.
Okay. Abhimanyu Kumar Soni, Abhimanyu, Abhimanyu, Arshit Mathur,
Present, ma'am.
thank you. Pooja Dotto,
Present, ma'am.
thank you.
मैम अमन कुमार मैम।
Kishan Kumar,
Present, ma'am.
What is your roll number?
Kishan,
Oh, that is
one.
your. When I call your name, you are absent. That time you didn't respond. What happened, Aman?
Ma'am, actually, ma'am, my internet was disconnected, ma'am.
Your internet was disconnected. Okay. Give me excuses after excuses not to attend the class.
Sorry.
Ma'am, Kishan Kumar. 1181.
Yeah, Kishan Kumar.
1181.
Yeah, thank you. Okay, thanks to all of you for attending my class. Thank you. I am leaving. Okay. Please submit the report by next Friday.
Yes,
Yes, ma'am.
Okay.
Thank you, ma'am.
Thank you.